We end up with some situations where we have service. You know what? That's dumb. Let me start over. So I was did a couple talks about moving data on and off the microcontroller. And in some ways, that's pretty trivial. But the idea is to build some discipline around the way you think about how you're doing this. It's especially true in a commercial environment, but even in your personal stuff. I mean, if you want it to be kind of long-lived, unlike me, who has a pile of boxes that I just use and go and play with and then do something else. You want to build some discipline around it. So one of the things that came out of those talks on moving data on and off the controller was, hey, there was a bunch of those talks that were identical. And so I just yanked them from the other blog article and put them in this one. And it was really about, if you're going to be making a decision, kind of what steps do you need to make? The first one, obviously, is what direction is the data going? Am I taking sensor data and sending it to the cloud? Am I sending control data from the cloud back, like to control the thermostat? Am I doing a display? And that means I'm sending status to the display, going in either direction, right? The next step is how you're going to handle connectivity and connection initiation. And so, it could be that you actually... And so you have data going in one direction or the other or both, and then you have who's going to set up the connection and how that's going to be set up, and what's the network going to look like? Is it going to be just a hard wire back to your PC? Is it going to the cloud? Is it going to be a Bluetooth thingy to something else? Is it to a hub? The hub then goes off the site, right? Those, at the very basic level, like when you're playing with this initially, it's probably just a Wi-Fi connection or it's something else. But the question is, who starts the connection? And I'll talk about that in a minute. And then you got to figure out how you're going to capture data. Is it going to be time-based or is it going to be interrupt-based? So if I'm gathering sensor data, that could be time-based, or it could be interrupt based on buttons and some other stuff. But when it's in the cloud and it's sending to you, is it going to be based on time, where they're going to send you data on a regular basis with status updates or with control? We're going to re-update the thermostat every 30 seconds, or is it going to be something that, it's a hockey light, and whenever there's a goal, we got to send a message to the light, or the light's got to pull. But either way, those were the connection. Which order direction is the connection going to happen? Is the light going to initiate a connection to the cloud, or is the cloud going to initiate a connection? That one probably pretty obvious, but you get the idea. And then you need to understand what the payloads are going to look like, and you're going to balance the CPU latency and other constraints. And it's like, am I doing a monster JSON thing? Am I sending just a number? Am I sending binary? Because it's super fast. Well, we'll talk about all of that, right? And so I think the first thing that I was going to look at was, what is the connection pattern? And so really, you've got the microcontroller and the cloud or external service, and then you've got either and I'm going to treat this as like primary data. So like so a thermostat would be one where it's both directions, right? The thermostat actually gets a temperature and sends it to the cloud, so the cloud knows, and then the cloud might also send commands to the thermostat to make changes to the temperature in the house, or building. And so, but those are actually might be two communication channels. And so the net is what's going to happen. And like in that case with the thermostat, what happens, right? It's the MCU, the microcontroller, that actually initiates the connection, and then the data can go both ways. So these four that I did, basically you do an initiate, and then the question is which direction is the transfer going to go, and that actually affects the way you build your application, right? So in the upper corner, the microcontroller initiates a connection to a cloud, and it transfers data to it. Or the microcontroller initiates a connection to a cloud and persists it, and then the cloud service can transfer data back, right? You get the same thing on a cloud service. If you had cloud services that were out trying to reach pumps somewhere, gas pumps, I worked one place, we actually told the cloud where the pumps were rather than having the pumps on board. And that way, I don't know why we did that. I don't remember anymore. But the idea was that the cloud service actually initiated the connection to the device. And you'll see that a lot, but a lot of times it's the peripheral that does it. So you could go either way anyway. The net is who's going to initiate the connection, the sender or the receiver, primary sender or receiver. And if you're going to send and receive, you're probably still only going to initiate in one direction. And you just got to figure that out, right? And that drives your firewalls, your credentials. Is there going to be a password on the device so somebody can connect into it? Oh, it connects to the cloud too. That means it needs credentials or certificates to talk to the clouds. So in that case, you might actually go both ways, right? So I drew these as individual, but these can be mixed with any combination depending on your network topology and what kind of security and what protocols you're going to run. So And the next thing to kind of think about is the triggering. Is it going to be an interval-based trigger for data transfer? Is it going to be an event? When I say transfer, that could also be for sensors. Now, if you're running a servo motor or a motor and you're doing closed loop control to figure out where you're at, none of this applies. I'm only talking about the part that goes to the external service or that comes from an external service or goes to a wired hub that it's attached to or comes from a wired hub. I'm not talking about anything that's closed loop on the device itself, where you got like a robot arm doing stuff. None of that is going to happen here, hopefully. But if we were going to send robot status or commands to the robot to do things, that would actually be this discussion. So you got to decide whether it's going to be interval or event-based. And here I did 6 events. And so we sent the temperature back on a regular interval, but we might do a mix, right? Because we might do regular intervals every 5 minutes. We send the current temperature, but if somebody changes the thermostat, we might send the message immediately, and then we'd fall back into a pattern, right? So in this one, the trigger-driven, it was an accident, but basically 3 of them were on the interval and the other 2 were interrupt. But they could have all been interrupt-based, and so you end up deciding event-based. So you got to decide, and it could be based on change, right? Not triggered. It could be, hey, if the temperature changes by more than 2 degrees, send a message. Otherwise, we don't have to tell it anything. And then every 20 minutes, we're going to send an update just so that it knows we're still alive, right? So when you're doing regular periodic updates, they're basically taken on a regular interval. And then what you might do, you could do internal sampling on that interval. Every 30 seconds, we take a sample, but we only send data if the temperature moves more than a certain amount. So, and we just might oversample. So we're going to send data every 10 minutes, but we're going to sample every 2 minutes. And that way, if it's been a long time, we don't wait the whole then if it was 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, and it changed in the middle somewhere, if it hadn't changed, we might end up deciding, we're going to oversample because we were doing event-based. And so we want it to be at least every 30 seconds or every couple minutes or when there's a change. So you got that kind of mixed thing. I'll talk about that below. So that oversample thing, not well explained, but if you think about it or ask me questions, I can answer that. And the problems with periodic updates are, of course, if the update doesn't happen, does that mean, actually, if we have periodic updates and we miss one, the beauty is that means we're probably down or we have some other problem. We can also do event-based, like I said, on the temperature. The downside of event-based, of course, is if there's no events, you can't tell if that means there's no events or the system's down completely. So sometimes you'll do the hybrid approach, which is really periodic for heartbeats just to show you're still up. So we give you a message every 5 minutes, no matter what. But if there's any changes in the status and the water level in the tank, we're going to give you that immediately. Right? So that would be a hybrid approach where you do some things on a periodic basis to guarantee a minimum fidelity in the data, and then you do the rest of it in the event. Probably the next thing I was looking at is this notion of batching or sending individual messages, and I'm going to be against my time limit here. Here we have periodic samples. Let's say we're doing samples every 5 minutes. And if we stream them, basically we would send a message within some latency off each sample. Right, so I got 4 here. We end up sending 4 messages. They're within some latency. That comes with its own expense. If I don't have persistent connections, I got to open a new connection for these. Each one I played with my ESP32, or maybe it was a Pico, and I could only get one of them was 4 and the other was 10 messages a second running a web server on them. So that constrained me to that number of samples per second. Right, and that was kind of running flat out, and could I have optimized it? Yep, and then I probably will. So that's what these guys would be. The other option is you say, I'm going to collect data every 5 seconds or every second, 10 times a second, but I know I can only send a message 4 times a second or once a second. So I'm going to record data here, actually every quarter of a second, and then every second I'm going to transfer it out in a larger packet. In that case, what I'm doing is I'm reducing the amount of connection management or packet building I got to do, but I'm making each packet slightly larger. So you got to figure out which way you want to do that, kind of a streaming, individual, and obviously there's mixes of this. Might not be one data point, it might be multiple. And then there's this batching pattern. The last one is you got to figure out what you're going to do for connectivity. And actually the direction of that connection I talked about above might really be based on what do the firewall look like, what are the routes, what's the DNS look like, blah, blah, blah. And the last thing is security and credentials. I don't have really time to cover for it, so we'll probably do it in another talk. And so that's this talk, right? What we're talking about is how do you initiate and manage connections with microcontrollers, and then how are you going to decide the period or the activity style, interrupt or periodic, and how are you going to manage the bulk or lots of smaller data points. And that's it. I'm out of time. I hope that's useful. This is all part of a bigger, it feels like this is an hour talk. Have a great day.